So let's begin with problems C and D. Like we'll be following this order of problems. C, then we'll go for D, then we'll go for probably A, then we can go for B, then we can go for E and F. Right? We'll do this. We'll do the problems in this order. Fine. So let's begin with C, and yeah. Also, my OneNote screen was visible to all of you, right? When I was writing that. Like I guess my whole screen is visible right now. I mean, can somebody just confirm that? Like,
yes,
I'm opening OneNote. Okay, fine. So yeah, let's begin with this problem. This is problem C, and the problem statement goes like this: that you've been given an array A, and you have to find another integer D. This D could be anything. Like if there are multiple values of D, we can print out any value. Okay, or do we have to print the minimum value? No, we don't have to print the minimum value. We just have to find out any D value for which a specific condition holds. And what is the specific condition? The condition is that if this is the array, no two adjacent elements of this array should be colored the same. So like if this is the array, and let's say I say that this is colored red, this is colored blue, this is colored red, this is colored blue. This is a fine coloring, but if I do something like red, blue, and blue, this won't work. This is not allowed. So I haven't told you the condition yet, but the condition is pretty simple. Like if I am choosing a value D and I iterate on my array, all the values that are divisible by D are sort of colored red. So let's say this value is divisible by D, it is colored red. Let's say the second value is also divisible by D, so it will be colored red. Let's say the third value is not divisible by D, so it will be colored blue. So you have to find such a D for which this particular condition holds, that for this whole array, no two adjacent elements are colored in the same color. Okay, so is the problem statement clear to everybody? And I'll prefer if you guys speak sort of, and not write it in the chat, because then I'll have to look at the chat again and again. Okay, so
it's clear.
Fine. So the problem statement is clear right now, and yeah, let's discuss the final approach. So can you see that there are only two types of coloring that are possible? Like if you consider this array, your first element could be R or your first element could be blue, right? Then the next element, I mean, if the first element is red, then the next element will have to be blue, right? So there is this possible coloring. And you can probably, increase it once more, and this is R. And similarly here, the possible coloring is this. Yeah. Right, so there are just two possible ways of coloring this whole array. So let's, find out whether any one of them is possible or not. If none of them is possible, then we don't, find the answer. I mean, then the answer is not possible. So what happens when I want to find out the answer using the first case? Like if I am doing this. Red are the elements which are divisible by D. Okay, let's just assume that right now. We are not we're not solving this problem very specific to what is given in the problem statement. So let's just assume that you want to do it like this. Okay. So tell me what should be my D value. If I want all these values, this value, and this value to be divisible by D, then what should be the biggest D value? First of all, tell me this.
GCD.
Okay, we are finding the biggest D. Finding the biggest D is equal to the GCD of all these, right? Like this is pretty simple. Like if you have a lot of elements and you want to find the biggest element that is divisible by all of them, that is defined by the GCD, which is the greatest common divisor. Right? So the point is, why am I not considering values that are smaller than this? For example, let's consider this array. Let's say we have 6, we have 5, then we have 6, then we have let's say 2, then we have 6, and then we have 3. Okay, and now let's say I want to color these elements red. So I can take the D value can be either of these. It can be 1, 2, 3, and 6. Why should I take 6? Tell me this first of all. Why is taking 6 the best possible choice that I have?
Because 6 is divisible by all.
6 is divisible by all. I mean, 6 divides all of them. That is the point. 6 divides all of them.
Divides all.
But 3 also divides all of them. Why am I not taking 3?
Because 3 divides 6
speak one at a time. Speak one at a time. Just a minute. Let Ashutosh speak. Yeah, Ashutosh.
3 will divide the last element as well. Last 3.
Yeah, it will divide, but how will I get this intuition during the contest? Why am I taking the biggest value? Okay, so
Because if it is divisible by the biggest, then it will definitely be divisible by other factors like 3, 2, 1.
Exactly. That is the point. Like I want to find just any single D value for which this condition holds. So why am I taking the biggest value? If let's say I have D and I have some divisor of this which is K. So if a particular element is divisible by D, it will also be divisible by K. Right? That is the condition. But right now what I want to check is that, if I'm saying that the odd elements are colored red, if I want this condition to hold, then the other condition that I want to hold is that, the even element should not be divisible by D. So if I'm taking a K, it has higher chances of, dividing a certain number than D. Like this is very simple. If you look at any value A, and if you look at 2, this will divide more numbers. And this will divide less numbers. So I should take the biggest value that I get, right? So this is very simple. I'll just quickly show you the code now. The logic is pretty simple. You just have to try out both ways, right? So this is what I'm doing. So first of all, I'm checking for the odd elements. I'm taking the GCD of all these values, and then I'm checking for the even elements, and I'm taking the GCD of all these values, right? Now I'm checking for both ways, whether possible 1 is true or possible 2. If any of them is true, then I print that answer, right? So first of all, what I'm checking is that, let's say, what is val2? Val2 is the GCD of all the elements in the even places. Right now I have taken I equals to 1, but in the 1 based indexing, this will be even, right? So what I'm doing is I'm just checking if all the odd elements are not divisible by the GCD of the even elements. So if that holds, then possible 1 will always be true. Otherwise it will become false. Similarly, if I'm saying that the even elements should not be divisible by the GCD of the odd elements, then possible 2 will remain true. Otherwise it will become false. Now let's say I tell you that both of them become false, that both of these ways are not possible, then you simply see out 0 because it is not possible. But now let's say possible 2 is not possible. This one. Yeah, let's say this one is not possible. What does this mean? This means that all the elements in the even places, some of them are divisible by the place in the odd one. I'll just put it like this. So if possible 2 is false, what does this mean? This means that all the elements in the even places, let's say this is this one, this one, similarly this one, then at least one of them is divisible by the GCD of the odd values. So I cannot take that odd value as D. What I will have to do is I will have to take this D as the GCD of even values, right? So tell me if this is clear or not.
Yeah, it's clear.
Right. And which was the problem that you were discussing? This was problem C. So yeah, I'll give you guys 1 more minute to sort of decide if you guys have any doubts, and then we can probably move to problem D. The intuition for GCD is very simple. Any number, if a number k divides a certain number x, then it's something like 2 into k might not divide x. Might not divide. That is the final intuition. Like you will have to take the biggest value that divides a whole chunk of numbers for it to not divide the other chunk of numbers. Right? Yeah. So let's move to problem D then. Then we can come to A and B. I'll just finish A and B very, very quickly. So anybody who's here for problem E and F, you won't have to wait so much. Right. Also, can somebody just tell me the time complexity of this one, problem C? Like the approach.
N log n.
N log of 1e18. Right, because I'm taking the GCD here. So this is like n into 60. So even if n here would have been something like 10 to the power 5, this would have been fine. Right? Yeah. So cool. Let's move to problem D then. And okay. So problem D is yeah. Problem D. The statement is pretty simple. The statement goes like this: that you have an integer n and then you have an integer k. N is the number of elements that you have in an array. So array A is also in the input. This is the array A, and this has n elements, right? Now you have this value k. This k, is the number of operations that you can perform on this array. So another condition that is given to us is k is less than equal to 2 into n. Now what is the operation that we can perform? The operation that we can perform on this array A is to select any two indices I and j, take their elements, let's say these are AI and AJ, and add either AI by AJ to your answer or add AJ by AI to your answer. Initially the answer is 0, right? You pick two elements from this whole array I and j, and you either add AI by AJ or you add AJ by AI to your answer. The condition that you want is that we can perform this, also when we perform this operation, the elements AI and AJ are lost, like they are removed from this array, right? So AI and AJ will be lost. Okay, and we can perform this operation at max k times. So tell me the number of elements that will be getting removed if I perform this operation k times.
2k.
2k.
2 and 2k.
Pretty simple, right? Now the condition is that I want my answer value to be minimized. Okay, another thing. After we perform these k operations, the remaining elements, whatever the remaining elements are there in the array, they will be added directly to my answer. For example, if I have 1, 2, 3, 4 and 5, and I perform this operation once using 4 and 5, and I add 4 by 5 to my answer. What is 4 by 5? This will be 0. So I am taking the floor value here when I am dividing. Okay, and let's say I perform this operation once, and then the other elements will be added directly. Like my overall answer will be 1 plus 2 plus 3 plus 4 by 5, which will be 0, which will be 6. Right? So this will be my final answer if I perform this operation once. I want to minimize this answer value. So I have to perform this operation k times. Now tell me this, if I have to perform this operation k times, which elements should I keep at the end? Like the number of elements that will be left will be n minus 2k, right? And these elements are... come again.
The smallest element that we have in the array.
Exactly. When we are saying that n minus 2k elements will be left and they will be added directly to my answer, then I should be ideally keeping the smallest n minus 2k elements for myself at the end. So let's say I have done that. This is a very greedy approach. I have n elements. I have picked the last 2k elements. Let's say these are 2k, and I have picked up these elements. So these are getting added directly, right? So these are added directly. This is very simple. The intuition is very simple here. If I have to keep these elements, I will want to keep the elements that are smallest. Now let's talk about the 2k elements. Let's talk about the biggest 2k elements. How should I, consider the values of AI by AJ? So let's consider this. Let's say I have 2n elements now, or in fact 2k elements. The other elements I've already added to my answer. So let's say the values, let's just first of all sort them. It doesn't harm us to sort them. So let's say I have values 3, 5, 5, 5, and we have let's say 7. So tell me, if I do something like 7 by 3, this will be 2, right? But instead of doing 7 by 3, shouldn't I always do 3 by 7? Because this will always be 0. Tell me this. Is this clear?
Yes.
Right.
Yes, it's clear.
So this is very simple. Whenever we are doing AI by AJ, then we should ensure that AI is less than equal to AJ, because then the value can be either 0 or 1. Right. Now you tell me this. There are two ways of solving this problem now. If I am saying that AI is less than equal to AJ, there are two ways of pairing the elements. Or in fact, there are many ways of pairing these elements, but let's just talk about two optimal ways. Let's say I pair these elements together. And sorry, let's just have two more elements. Let's say I have 7 here. So one more element. So also this would be hidden by my video, I guess. Let me just see. Okay, this is fine. Yeah. So let's say I've pair these elements like this. So what will be the answer? 3 by 5 plus 5 by 5 plus 7 by 7. What will be the answer here? The answer will be 2. But let's say I decide to pair the elements like this. I pair this 3 and then I pair the kth element. I pair this up with this. Then I pair this element with this and then I pair this element with this. So the answer will be what? The answer will be 3 by 5 plus 5 by 7 plus 5 by 7. Which one is more optimal?
The second one.
Exactly. And there is just one more edge case which a lot of people would have missed. I am pretty sure a lot of people would have missed this, which is very simple. There are 3 ways of doing this, but I only showed you the 2 ways. I showed you the 2 ways as pairing these elements like this. Like this. Pairing 2 elements which are adjacent, right? Another way was what? Another way was simple. Pair this element, pair it with the kth element. Pair this one with this kth. Pair this one with this one. Another way is very, very common. This is a very common intuition that you can get, which is to pair, first and the last element, then this element and this element. This is very common. A lot of people would have done this for sure, but this is wrong. let's say I pair them up like this. And where exactly is this wrong? In the previous test case that I showed you. You can have something like 3, 5, 5, 5 let's say, and 7, 7. So if you pair them up like this is 3 by 7, which is 0. Then if you pair these elements, which is 5 by 7, which is 0. Then if you pair these one, this is 5 by 5. So the only optimal way of doing this is to pair the first element with the kth element, the second element with the k plus first element. Right? So is this making sense to everybody now? Like, I'm pretty sure a lot of you would have done this like this as well, and this is wrong. So this is the test case which might be failing. Right? So is there anybody who did it like this and sort of got a wrong answer?
Yeah, I did it like
Yeah,
that.
I did it. I also did it like that.
But I tried second one as well to take alternately.
I think this passed sample test case, so we are safe by that.
What, this passed the sample test case is this one?
So this failed the sample test case itself, so
Yeah.
that got eliminated.
Yeah, fine. I mean, if this would have passed the sample test cases, I would have left this Zoom call and probably got into hacking. Yeah. Anyway, so I guess now it should be clear the problem, and I guess I also did it like this. The first time I also did it like this, or I sort of paired the adjacent elements, and this was giving a wrong answer on test 1. So that is somewhere. Yeah, I was pairing the adjacent elements. Can you see here? But this was wrong. And yeah, let me show you my final code for this. I know I have implemented this like in a very different way. A lot of you would have done this from left to right, or I don't know how you would have done this, but there are multiple ways of implementing it in a very complex way. I'll tell you how I did it myself. So what I'm doing is very simple. I have this array A. I sorted it first of all, and then I reversed it. Why did I reverse it? Because I need to pick the last 2k elements. If I want to pick the last 2k elements, why shouldn't I just reverse it and pick the first 2k elements? Right? So I reversed this, and this sort of helped me implement it faster. Oh, sorry. I guess there was a lot of noise. Anyway, so yeah, this is what I've done here. I have first of all sorted this array, then I've reversed it, and then I'm taking this. I am pairing the I plus kth element with the ith element. Right? And I mean, if I reverse it, then this will be in decreasing order. This is very simple. First of all, it is in increasing order. If I reverse it, it will be in decreasing order. So I will have to pair AI such that AI is greater than or equal to AJ. And I will be doing AJ by AI. Right? So, like, is this clear to everybody now? This was not a very big code.
Yes.
Cool. And also I sort of, started giving this contest, I guess around after 13 or 14 minutes, the contest actually started because I was sort of busy with something. So I started directly from problem D. I wasn't in the mood of even attempting this this contest, but then the problem D looked very easy, so I sort of implemented it like this. I went from D to C, B, A, and then I went for E and F. So yeah, I guess now we can go for problem B or problem A, whichever you like. Which one should I discuss?
Can we go for E and F instead?
I mean, I would hardly take 5 minutes for this, for problem B and A combined. I can go for problem A very
For
quickly.
problem B, first, can we go for problem B?
Yeah, sure. We can go for problem B. That sounds great. Yeah.
Priyansh, can I add one thing?
Yeah, sure.
Yeah, actually, there was one more way of thinking about problem D. So basically, if you have like for the last 2k elements, if the frequency of any element is not more than k, then you can always have unique pairs such that both the pairs are unequal. So in that case, the ratio will always be 0.
This is also a good
So-
approach. Yeah.
Yeah, even I implemented through this only. But like
Yeah, so in
in
fact,
your
you
approach,
don't
why
need to
are we
think about it.
taking like k gap,
I mean,
a gap of k?
isn't this very clear? Like if you want to pair elements, you should be pairing elements that are as far apart as as they can be. Let me just make it very clear. Here what I'm doing is I'm taking elements that are k apart. This is the minimum, this is the maximum that I can do. Can I pair elements that are, let's say k plus 2 apart? If I pair two elements that are k plus 2 apart, I will have to pair some elements that are k minus 2 apart. Right? Does this make sense to you?
Yeah.
So if I have to do it like this, and if I get into this situation where I have to do k minus 2, why shouldn't I always do k? I mean that was the intuition behind it. But there is not like a proper proof that this will always work. I don't have a proof for it. But I guess this should be clear. Like it is very simple that you can have the gap of argmax k. If you don't want to have the gap of argmax k, then then you can probably pair some elements that don't have a gap of k, and pair elements that have a gap of less than k, probably. Not really sure how to explain this. Yeah, so the person who was suggesting this, like, let's say the frequency of a certain element is greater than k, what do you do then? Let's say we have 3 and we have 5 many times, and then we have 7. So what do you do in this case when you have a lot of when you have a single value occurring more than k times?
So yeah, in that case, like the answer will be just the maximum, like the frequency of 5 is maximum here. So subtract k from it, and that will be the answer.
Pretty cool.
So like
nice.
Because yeah.
So this is nice. So what you can do is, if you want to pair elements, then if one of the elements has bigger than frequency, if one of the elements has a frequency bigger than k, then this is what you can do. Let's say this is the element that has frequency bigger than k, and these are the other elements. You can pair these like this, and the elements that are left you can sort of have something like a by 2. Like this is something that you will be adding if a elements are remaining here. So yeah, this also works. Good approach. Right, so yeah, I guess we can now move to problem B. Yeah. Okay, somehow my internet. No, this is working fine. So I am audible to everybody, right? There is no lag or something. Okay. So yeah, let's discuss problem B. Problem B again is very simple. You have a string which goes something like this: A, B. I mean, this string only has characters A, B. Okay. Probably I can change the ink color here. It should look better. Let's leave this. So we have this string and it looks something like A, B, B, A, B, B, A, so on. Okay, and you pick up every 2 elements from this string and you write them down. For example, if this is the string, the 2 elements, if I pick them adjacently, will be like this: A, B, 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 A, B, 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 A. Okay, so I mean, right now we don't have the string, but we have this sequence. If let's say I give you a sequence, can you construct the final string? If I don't remove anything from here, if this is a valid sequence, can you construct the final string?
Yes.
How will you construct it?
Yes.
Let's first of all define this. Let's say I have A, B, B, A, B, and B. How will you construct the final string from this?
Like we'll remove the second adjacent element from the second diagram. Sorry, like in this example, I'll tell you A will be as it is. We'll remove the first A in this second
Okay, we remove this one.
sequence. Yeah.
Okay. Yeah. Then. Okay. So then we got this and then we removed this. Okay. Right. Fine. So then we got B and we removed this. Then we got A and we removed. Sorry. We got B and then we removed this. Then we got A,
yes,
and then we removed this. Then we got A again, and we removed this B. This is what you're doing, right? Yeah. Then we got B, and the last element will be taken. So if you construct the sequence for this string, you will have A, B, B, B. Right. So I'm getting the exact string here. Like this is matching here. This is matching here. Okay. Do I have? I guess I missed something.
Basically, the second letter of every pair will give you the original string, and including the first letter of the first pair.
That also works. You can do it like if I tell you that I have the final sequence, you can construct the string in 2 ways. Take first character of first pair that we have, and then you pick up all the pairs and pick up only the second character of all. Or let me just write it on Sublime, that should be better. Right, yeah. Okay. Right. So, there are just 2 ways. Complete sequence is given. So So the first way is very simple. Either you have, first character, first pair, plus, second character of all others. Or the second way could be, first character of all pairs except the last, plus, second character of last. Right, so is this clear that, if I do this, this will give me the final string if provided, I have the complete sequence.
Yes.
Right. Now let's say I tell you that one of the sequence in between is removed. Oh, sorry, just a minute. I'm not sure what did I do right here. Anyway. So let's say I have the sequence and I remove one of them. Let's say I have something like AA, BA, sorry. And can you also see that, if you consider any two adjacent, pairs in this sequence, then the second character of the first one will match the first character of the second one. Like, is this clear to everybody? That if I have something like this, AA, AB, I can never have A here. If I have something like this means that there is a missing pair here. Right? And if I don't have any missing pair, for example, if I have something like, if this is a consistent string, if I have something like this, then I can probably put up a last character at the end.
Yes.
Right. So there are like two ways. There are two possible cases. If you iterate from left to right, and I tell you that in this pair, or let's say I put it like this, that in this pair and in this pair, the second character here is not matching with the first character here. Can I say that the missing pair that I have will be here only? Can I say this?
Yes, definitely.
And let's say I have something like A, B, and then I have AB. What will be the missing character here? What will be the missing pair here? Tell me this.
BA.
The missing pair will be BA, right? So this is how it will go. And let's say I don't get any, I don't get any of these. Like, I don't encounter any of this situation where the second character of the first pair doesn't match with the first character of the second pair. What do I do then? Can I just insert anything at the end? Like if I have here AB, I can just insert BA at the end, right? Or I can insert BB at the end. Anything I want.
Yes.
Yeah.
Right. So if I do this, then can I just construct my final string? If I have the complete sequence, then.
Yes.
Right. So this is very simple. What else is there to explain in this? Like you just have to iterate from left to right and check if the second character of the first pair doesn't match with the first character of the second pair. You insert that pair in middle and generate the final string at the end. If none of this happens, then at the end you can insert any pair that you want, such that its first character matches with the last character of the last pair. Right. So that is exactly what I'm doing. I'm just checking. I'm just iterating from here to till the end, and I'm checking if I get into such a situation, then I'm adding this to my answer. Like I'm constructing my string also at this point only, right? So I'm not sure if this makes sense here, but yeah. And if such a situation never arises, then I can just probably add an A at the end or add a B at the end. Anything will work, right? So now tell me if this is clear or not. Problem B.
Yes.
Okay. I'm not sure if the implementation is clear, but I won't get into the implementation right now. You guys can code it up yourself. And let's get to problem A. This is very simple. I would take like hardly 2 minutes to explain this. So yeah, you have 3 positive integers. The important part is that all of them are positive. Okay, this question only makes sense if all of the integers are positive. So you have A, B, and C. Let's just assume right now that A is less than equal to B and B is less than equal to C. Let's just assume that right now. Okay, considering them in a random order won't make sense, right? So let's just assume that they're in a sorted order. So you make, you consider all these subsequences like A, AB, AC, then you have BC, then you have, what else do you have? You have, you have B also here, right? You have ABC, you have AB, AC, and BC, and then you have ABC. So there are like 7 possible subsequences of this, and all of their sum is given to you. Like this is given to you. A is given to you, B is given to you, C is given to you, AB is given to you, BC is given to you, CA is given to you, and ABC is also given to you. All you have to do is, and also they're given in sorted order. Like you have this, even if you don't have a sorted order, this makes sense that, ABC will be having the highest value. Does this make sense? That ABC will be having the highest value.
Yes.
Okay. So let me just write it on Sublime here. So you have 7 possible, subsequences A, B, C, A, B. BC, AC, and then you have ABC. So can you see that if I consider this condition that A is less than equal to B is less than equal to C, can I always say that if I consider these elements in a sorted order, then the last element will be ABC? ABC. The last element will be ABC and the first element will be A. Can I say this?
Yes.
What about the second element? Wouldn't the second element be B?
Yes.
Or will it be anything else? Can it be anything else?
No, the smallest possible like number after A.
Exactly. So if I have A, if I have A, if I have B, and I also have ABC, can I find C?
Yes.
How will I find C? Yeah. So C is equal to nothing but ABC minus A minus B. Right. So this is exactly what you need to do in this problem, and yeah, I have sort of implemented it in a little different way, but that is all that is there in this problem. Right. So yeah, let me just show you what I've implemented. So I have taken ARR, I mean this is my A value, ARR of 6 minus ARR of 5. Why am I doing this? Because if I consider this ABC, what will be this value? Can I also say that this value will be BC here? Will it be wrong to say that this is BC, the second highest value?
Yes, it will be BC.
Not necessarily BC.
Why would it not be necessarily BC? Tell me which can it be?
Oh, after sorting. Okay.
Yeah,
Yes.
after sorting. So
Yes,
the next
yes.
value will be BC, right? So I can get my A equals to as this also, right? ABC minus BC. So this is what I did. And then the second value will be, the second value is fixed, and then I got my third value as this. Right? So yeah. Cool. So I guess now we're done with problems A, B, C, and D. And if there is anybody who wasn't able to solve even till problem, sort of B, then I wouldn't recommend attending this, post-contest discussion after this point, because problems E and F will definitely be will be very tough, and I won't be answering trivial doubts here. Right. So you guys are free to leave if you don't have any more doubts around problems A, B, C, D. But I'll just wait for another 1 minute, and if you guys have any doubts, I can answer them.
भैया मेरे को ये पूछना था कि एबीसी आपने सॉर्टेड अज्यूम किया, क्वेश्चन में तो सॉर्टेड नहीं था, तो हम कैसे, मतलब मेरे को समझ नहीं आया कि आपने सेकंड बी कैसे क्यों लिया.
The point is very simple. I get to print my answer as in as I like. They did not tell me that I have to print the answer in a sequence, that I have to print A1 first, then A2, then A3.
ओके. सो जैसे कि पहले का आंसर 1 4 3 है, तो मैं 1 3 4 भी कर देता तो सही होता.
हाँ.
ओ मैंने गलत अज्यूम कर लिया, तभी डी हो गया था, तो इस वजह से मैं ए नहीं कर पाया. मेरे को लगा सेम ओरिजिनल ऑर्डर में कन्वर्ट करना है. वहां पे लिखा है देयर कैन बी सेवरल आंसर्स प्रिंट एनी.
हाँ, मतलब ये तो काफी कॉमन चीज है कोड फोर्सेस पे. आई गेस यहाँ पे लिखा है. हाँ, ये अगर ऐसा होता है तो तुम्हें पता लगाना चाहिए कि मतलब तुम्हें पता चल जाना चाहिए इनफैक्ट कि यू
मेरा पहला कॉन्टेस्ट हो गया.
कोई बात नहीं, बढ़िया है. मतलब तुमने प्रॉब्लम बी कर दी, काफी बढ़िया बात है. ठीक है, तो या आई गेस नाउ वी कैन गो फॉर प्रॉब्लम ई. सो या ठीक है, प्रॉब्लम ई में ना बस थोड़ी सी मैथ्स है, थोड़ी लीनियर इक्वेशंस हैं, ज्यादा कुछ नहीं है. वंस यू गेट द हैंग ऑफ इट, इट इज वेरी इजी टू सॉर्ट ऑफ इम्प्लीमेंट इट. सो लेट्स डिस्कस व्हाट इज देयर इन प्रॉब्लम ई. So let me just write it here itself. So in this problem, first of all, let's say that you have an array A, okay, and you have certain values like this, A1, A2, so on up till AN. What you do is you go to every value and then you start moving from it to in the clockwise direction. So let's say I am on A1, I'll add A1 to this value, and then I'll add 2 into A1 to this value, then I'll add 3 into A1 to this value, and so on, and then at the end I'll add n into A1 here. I mean, let's just consider a B vector, okay? First of all, just a minute, B is equal to empty. Right now B is empty, okay? So I go in B and I add these values. I go at A1, I go at the first index, I add A1. Then I go at the second index, I add 2 into A1. Then I go at the third index and I add 3 into A1. So on, at the end I add n into A1. Now again I go for A2. So let's leave the first value right now. Then I go for A2 and I add A2. I add 2 into A2 at the third place, so on. At the end I add n minus 1 into A2. Okay, and then here, as I'm going in the clockwise direction, I'll come here and I'll add n into A2. Right, so is the sequence making sense to everybody, that I'll be going like this and I'll go down Right? Tell me if this is making sense right now.
Yes.
Okay, so tell me what will be the value. Okay, just a minute. I guess there is a lot of lag here. Yeah, probably because I have my Zoom also open and my screen is getting shared in both the places, and both the webcams are on as well. So tell me what will be B1. What will be the value here? Wouldn't be something like this: A1 plus n into A2 plus n minus 1 into A3, so on into 2 into n. Will this be the value or will this be something different? Like I can write it for 3 as well. Like what will happen when you have 3? So you have n minus 1 into A3, then you have n into A3, then you have A3, then you have 2 into A3, so on, then you have at the end n minus 2 into A3. Okay, so tell me if this is making sense, that the value in B1 will be this. It should be A1 plus n into A2. Yeah, that is exactly what I've written, right? A1 plus n into A2 plus n minus 1 into A3.
आपने प्रोडक्ट कर रखा है वहाँ पे.
Sorry. This is yeah, cool. Right, so now is this clear? Now is this fine? What will be B2? What will be B2? This will be this will be 2 into A1 plus A2 plus n into A3 plus n minus 1 into A4, so on. At the end we'll have 3 into n, right? Is this fine?
Yes, it's fine.
Okay, now let's say I tell you what will be this. What will be B1 plus B2 plus B3, so on up till Bn. Okay, let me just give you a disclaimer for anybody who's not read this problem. Initially we don't have this array A, we only have this array B, and we want to find the original array. That is there in this, that is all that is there in this problem. Okay, so I guess the problem statement is clear to everybody. Is there anybody who's sort of struggling with the statement itself? Okay, assuming that there is nobody then. Now tell me what will be the value of this?
Sum of n into n plus 1 by 2 plus value or sum of values of A1.
Nice. Tell me what will be Bn first of all. Wouldn't this be n into A1 plus n minus 1 into A2, so on up till An? Like is this condition right? Is this expression right?
Yeah. Yes.
So can you see that for any value A1, A2, A3, so on up till An, all of these values are getting added like 1 plus 2 plus 3, so on up till n times. So that will be like n into n plus 1 by 2 times A1 plus A2, so on An. Tell me if this condition is making sense.
Yeah, totally.
Okay. Now tell me if B1 plus B2 plus B3, so on up till Bn is not divisible by this value. Will this ever hold? Will this equation ever hold?
No, we will not be having a.
Okay, so the first condition is if sum of B1 plus B2 so on up till Bn is not divisible by n into, the condition is not possible, right? So this is the very first condition that you will have to think about. And I know it is very, very difficult to think about all these equations during the contest, but that is how it is for a lot of linear equation problems. Like this is not exactly a linear equation problem, but you will have to sort of apply your mind to get these equations, right? So is this condition fine? Can we move ahead?
Yeah.
Okay, so tell me what is A1 plus A2 so on up till An. What is this value? Like in terms of this.
Sum of B1 plus B2 divided by n into n plus 1 by 2.
Okay, sum of B is divided by. Okay, also let's take n into n plus 1 by 2 as something like val. Okay, let's define a variable. So now tell me, wouldn't this be something like divided by val? Let's take this as sum. So tell me if this equation is now right or not.
It's correct.
Okay. Now tell me this. What is B2 minus B1? look at this equation and tell me what is B2 minus B1. First of all, tell me in terms of A1. Can I say that, A1 is like getting added once? Can I say this? If you take B2 minus B1, subtract the first equation from the second one. Tell me what will be the answer here. If you look at A1, can you see that A1 is getting once added to B2 from B1?
Yes.
What about A2? Can I say that it is getting added minus of n minus 1 times? This is n, this is 1. So I am getting n minus 1 and then I have to subtract it. So like that will be 1 minus n, right? What about A3? What about A3? How many times is it getting added to form B2 from B1?
Once.
Once, okay. And what about A4? Can I again say it is getting added once and so on up till AN? Can I say this? Is this a right equation?
Yes. A4 will be added twice.
A4 will be added twice. Why? Let's see. We have plus, n minus 2 into A4. This is what we have. And here we have n minus 1. Why will A4 be getting added twice? When I am saying go from B1 to B2, I am finding B2 minus B1. Look at this equation once again. I'll give you 10 more or 15 more seconds to understand it. Yeah, now tell me if this is clear or not. Correct. Now can you see that if I sort of, simplify it a little, this is nothing but A1 plus A2 plus A3 so on up till AN minus n times AN, A2. Can I say this? And I already know this. I know B2 minus B1. I also know A1 plus A2 plus A3 so on up till AN. So I can say B2 minus B1 equals to sum minus n times A2. I already know everything here except A2. So can I find A2? A2 will be what? A2 will be B2 minus B1 minus sum divided by n. And I'll take the negative of this. So tell me if this is fine or not. Haven't I found my A2?
Yes.
I have found my A2, right? But there is one condition again. Can I find my A2 if B2 minus B1 minus sum is not divisible by n? Tell me this. So if B2 minus B1 minus sum is not divisible by n, then is the answer not possible again?
Yes.
Right? Because this is a very simple equation. This is like an exact term. I don't have any other possibility. Right? Similarly, can't I say A3 equals to, minus of B3 minus B2 minus sum divided by n? Can't I say this?
Yes.
I mean, I'm not going to go into the casework again. You can write B3, then you can write B2 and you can find this. You will get this exact term. Similarly, A1, I mean AN equals to, let's write AN first of all. This will be what? This will be AN minus A of n minus 1 minus sum divided by n. Similarly, A1 equals to minus of A1 minus AN minus sum. Now, how am I getting this value? Because this is cyclic. This whole array is cyclic. Right, so now can you find all these A values? I think now it should be clear.
Yes, we are clear.
Okay, fine. So I'll just give you a very small, thing. I mean, I'll just give you a very small summary again. We have this B array, which will be constructed like this, and then we have to find the A array from this. So what I did was I wrote equation for every single B value. I wrote it like this, right? And after that, I looked at this value, B1 plus B2, so on up till Bn. And this comes out to be nothing but n into n plus 1 divided by 2 into the sum of all A values. So my first condition is that if this value is not divisible by n into n plus 1 by 2, then it is not possible. Similarly, what I do is after that, I find my A1 plus A2 so on up till An, which will be sum by val. And then I consider this equation, B2 minus B1 and B3 minus B2, B4 minus B3, so on, and I get these equations. After that, at the end, I have my values. There is just one thing I need to check. All of these A values should be greater than 0. This is very important. I guess some of you would have missed this as well. This thing. A values are all greater than 0. This is written here. Where was this written? Yeah, here. So did somebody get a wrong answer even after solving this problem correctly and not checking for this condition? Not really sure if somebody got it, but this is another edge case that you need to take care of. So I'll just show you my code for this, and I also wrote down the equations, like I was considering it this way only while solving the problem. So yeah, at the end I'm just considering this. This is a very important edge case. I guess
didn't got B2 minus B1 wala thing in the contest.
This is a very common thing. ये हल्के हल्के आ जाएगा, ठीक है? This is not okay. Sorry, internet connection is unstable. Just a minute.
It's fine actually.
No, the thing is that my college internet gets locked out, so I'll have to keep checking again and again. Right, so this is exactly what I was doing, and this is also a very common thing. Okay, like this difference array. This is bi minus 1 is nothing but a difference array. Okay, so this was a problem based on difference array. So anybody in level 1 who has sort of studied about difference array can try to solve this. Although this is a very difficult difference array problem. Okay, so can we move to problem F? Is problem E clear, and are there no more doubts?
Yes. Hello.
Yeah.
भैया आपने ना ये जो B2 minus B1 वाला आइडिया है ना, तो ये मतलब आपने सोचा ये करना क्यों सोचा इस क्वेश्चन में आपने?
नहीं, ऐसा कुछ उसका वजह नहीं होती. It comes up naturally when you do a lot of problem solving. These things like these come up naturally, like subtracting, adding, terms. This came up naturally to me. B1, B2, so on. And then
हाँ, मतलब ये मैंने कर लिया था. ये मैंने लाइन 36 तक मैंने भी कर लिया था, मतलब एग्जाम कॉन्टेस्ट के बीच में. बट B2 minus B1 करके ये इक्वेशन को ऐसे सॉल्व करना नहीं सोचा था.
इनफैक्ट मैंने सीधे B2 minus B1 नहीं सोचा था. सबसे पहले I went for B1 minus Bn. I was thinking of this whole thing in an anti-clockwise direction. ऐसा नहीं कह रहा हूँ, मैंने प्रॉब्लम गलत पढ़ ली थी, बट इट इज जस्ट दैट आई वाज थिंकिंग अराउंड दैट लाइन मोर कि B1 minus Bn करता हूँ instead of doing this B2 minus B1.
I was thinking on JFG, is there any Cramer rule applicable to n cross n?
Sorry, is there any what? Is there any what rule available? I'm not sure if I got that.
Cramer rule for solving system of linear equation, or Gaussian elimination or something, so that we can solve it.
There is something like that, but I don't know how to do that. I don't know how to code it up.
Even though if we try to do in that way, the matrix will be n cross n. That won't be possible.
But I guess still doing that using some fast Fourier transform or something like that comes out to be n log n. Like there are ways to solve those linear equations as well. But I am not aware of that. I have never studied them.
Is there any source to practice these difference array problems?
I mean, I'm not really sure. If
a good source that you can suggest.
I haven't come across a lot of difference array problems. It is just that it is very difficult to identify that you have to take the difference array. But once you solve around 5 to 6 problems, you get the hang of it. So I'll have to look for problems around difference array to give you guys. But I cannot guarantee right now that I'll be looking for it right now. But yeah, I will look for some problems and I can give them to you in DLE. Can you please tell it which rating E question is? I don't think this will be a lot. 1800, I guess. 18 or 17 also it could be. Yeah. Okay, let's come to this problem. This was like an interesting problem. Again, I would say constructive algorithms only. Okay, so we don't have a tag of constructive algorithms here, but yeah, it looked like constructive only. Anyway, so let me just explain the problem statement very briefly. So what you have is, let's say you have an initial element x and you convert it to its binary form. Okay, just a minute. Yeah, so you have an element x and you convert it to its binary form. Let's say binary form comes out to be something like this. Okay, and let's say we have another 0. So what you do is you perform certain operations on x. Let's say, there are just two types of operation. You add a 0 to x and you then reverse this whole string. Or you add a 1 to x and you reverse this whole string. So let's consider two ways, when you add a 0 and when you add a 1. Okay, so let's say x is something like this, 1 0 1 0 0 0 1 0 0. Okay, now let's say I add a 0 and reverse it. What will be the string? The string will be 0 0 0 1 0 0 1 0 1. But I don't have to consider the leading 0, so I will remove this. Okay, so this is the string that I get when I add a 0 to it and reverse it. Now let's say I add a 1 to it and I reverse it. What will I get? I will get 1 0 0 1 0 0 1 0 1. Okay, so are these two strings clear to you? Like, is the formation clear to you? A and B? Somebody can maybe confirm if this is clear or if I'm not audible itself. Okay. Just a minute. Yeah. So now let's say this is clear. So tell me this. If I have my string as this, 1 0 0 1 0 0 1 0 1. Okay. If I add a 0 to it, will it make a difference? If I add a 0 to it and I reverse it, will it make a difference?
No.
Okay. Anyway, if I do this 1 0 0 1 0 0 1 0 0, if I add a 0 to it, will it make a difference?
Yes, obviously.
It will, because these leading zeros will go away, right? So can you see that once you have a string which has ones at both the ends, something like this. If you have ones at both the ends, whenever you add a 0, the string won't change. The string will get reversed. That is fine. The string will get reversed. If I have something like this, it will get reversed, but any characters won't change. Right? So is this fine? Is this making sense till now?
Yeah.
Yes, we are.
Fine. Another thing is that these are some observations. Let me just jot down these observations, then it will be very clear. So first observation is this. Observations. Let's write it like this. If you have a string as something like this, adding a 0 to string with ending zeros removes all zeros. Right. So I guess this is fine, right? This first observation. Second observation is this, that if you have a string something like this, adding a 0 to a string with ones at both ends does nothing. Right, so is this also fine?
Yes.
Okay, another observation is adding a 1 to a string always changes the string. Right, this also should be fine. Another thing is this, we can always reverse a string. Right, this is also another observation. When can we do this? We can only do this when both ends have zeros. Both ends have 1, sorry. Okay. Now tell me which of the ends of the string can have a 0 sometimes. Can the left end of the string have a 0 ever?
No.
Only the right end of the string can have a 0. Okay, so these are the basic 5 observations. All we have to do is we have to check if we can convert x to y or not. We have to check this. Okay, so we have an integer x, then we want to convert it to y, and we have to check whether this is possible or not. So can't I say this, that if let's say I have my x as something like, if x is ending with both ones, if this is my x, can I say that the only string that I can form after this is just adding ones here and adding ones here? Can I ever add a 0 in between? Ever? Tell me this. If I have my string x which has both ones at the ends, can I ever add a 0 now here? Look at this observation. Adding a 0 to a string with ones at both the ends does nothing. Right? Can I do something and can I have something like 0, 0, 1 here now, and after that 1, 1, 1 maybe? Can this string be ever reached? It can never, right? So this is very simple. First of all, if let's say you have your string x which has zeros at one of its ends. Let's say this is your string x. You have something like 1, 1, 1, 1. You construct two strings out of it. One of them remaining this 1, 0, 0 this, and another string you keep it like this. You have 1, 0, 0, 1, 1, 1, 0. Sorry. You basically remove all the zeros. Just construct two strings, these and this, and try to form the answer from this. There is no other string that you can generate in the initial step. After this, let's say I tell you that the string has ones at both the ends. This makes it fixed, right? You can only add ones in the left and the right end, and you can reverse this part. You can reverse the middle part and only add ones at the right end and at the left end. Right? So let's write it like this here. Once the string has ones at both ends, we can only add one in the left or right, never a zero, right? And we can also we can also reverse, right? So tell me if this is making sense. Once the string has ones at both the ends, we can only add ones now. We can never add a zero, because if we add a zero, it won't make a difference. This zero will never be getting added, because that will always be a leading zero. Right? Let me just construct an example here. Okay. Yeah. Okay, I might have to trim that part wherein I opened OneNote. Microsoft To Do. So I will have to trim that part out of the video anyway. So let's say I have this string, let's say this is 0 and 1. Now let's say if I add a 0, will this ever make a difference? If I reverse the string, this 0 will go away, right?
Yes.
So whenever I have a string which has ones at both the ends, now it can only be, we can only add ones at both the ends. So this is very simple. If you have x here, you construct two strings out of it, one a and one b. A is constructed when you add a 1 at the end of x and you reverse it. So you will have something like, anything like this. But can we say that if once we perform one single operation on x, both of its ends will have a 1? Can I say this? Anything, Can I say this, that once I do the first operation on x, either I add a 0 or I add a 1, both of x's ends will be having a 1 now.
Yes, we can say that.
Yes. We can say this. So let me write that as well. So let's say I have string a as something like this, 1, 0, 0, It has both ones at the ends, and I have string b as something like this. Okay, I have two strings a and b, and now I have to convert them both to, any of them to y. Right? Let's say y is something like this. Can I say that if I have to make a equal to y, then a has to be a substring of y and all the other elements have to be 1? Can I say this? Like, all the elements on the left or on the right will have to be a 1. Can I say this? Like, if I have a, how can I change a now? I can only add ones, right? I can add 1 to the left end or I can add 1 to the right end. I can never add a 0 now. So this is very simple, that a has to occur as a substring in between y, either a or the reversed. Because we are also allowed to reverse it, right? After performing the first operation on x, you perform one operation using 1, then you perform one operation using 0, right? You just have to check if, if this string occurs in this y string as a substring and all the other elements which are not included in the substring are 1 or not. So that is exactly what I'm doing in the final solution. Yeah, so tell me if this is clear or not.
Yeah, it is.
Yeah, it is.
In this case, we are checking for if we can convert A into Y or not, right?
Yeah.
Okay.
Or the reverse as well here. I mean, you will be doing this only after checking if x is not equal to y. If x equals to y, then you already have your answer. If you don't have x equals to y, then you will have to perform one of the operations, right? So either you perform the operation adding 1 or you perform the operation adding 0. If you add 0, all the leading zeros will be gone. If you add a 1, nothing will be gone, but another 1 will be added. So after performing the first operation, both the ends in A and B will have 1. And if that is the condition, now we can only add ones after this. Right? So A or B has to occur as a substring in Y, and all of the other elements have to be 1. Right? So, yeah. So this is exactly what I'm doing. Here I'm checking if this is possible or not. I'm checking for substring. Here I'm checking if the substring equals to this or the reverse of this, and I'm checking if all the other characters are ones or not. Here I'm checking that. So here I'm doing, I'm either checking on A1 is the string that I'm considering as X, or I'm checking on the, string that I get after performing one operation on it. Okay, so now tell me if everything is clear, or if you guys have any more doubts.
Can you tell in A, like in X, Y, and the given string that you took in the last case example, in the notepad A, B, and Y, in those strings, which are the given strings and which are the strings we are checking for? Like,
X is the given string, A is the string constructed. Okay, now is this fine?
Yeah, it's better.
Okay. So these were the 5 observations. What are these 5 observations? Adding a 0 to a string with zeros, ending with zeros, removes all the zeros at the end, because then the string will get reversed and the leading zeros will be gone. Similarly, adding a string to a 0 with both, with both ends having ones will do nothing. It will just simply reverse the string. Right? This is the second observation. Third observation is adding a 1 to a string always changes the string. I mean, once you add a 1, everything will remain same, but just there will be an extra 1. And similarly, we can always reverse a string without any issue, provided both of its ends have ones. And only the right end of the string can have a 0. The left end can never have a 0. Right? So these were all the observations and the final solution. Right? So can we end it now, or do you guys have any more doubts?
Can you tell how did you construct the string A and B again, like in short?
Yeah, sure. So let's say I have X. Let's consider an example. Let's say I have this 1 0 0 1 0 1 0 0 1 0 0 1. Let's say this is your X. Let's say I add a 0 to it. What will be the and a reverse? What will be the new string? Tell me this.
The string in reverse order, but ignoring the last zeros.
Yeah. This will be the string, right? And I'll remove this.
Yeah.
Right. And similarly, if I add a 1 here, what will be the string? The string will be this. Right?
Yeah.
So what have I written here? A is the string when I add 1 to it. So A is this and B is this. Now I have to check whether any of them is convertible to Y or not. So all I'm doing is I'm checking if either of them is a substring of Y, and all the other characters that are not a part of the substring, they are 1 or not. This is what I'm checking. Right? Now I guess.
Okay.
Cool.
Yeah, it's crystal clear now.
Cool. Okay, so then I'll probably end it, and I guess now everybody should be able to upsolve till problem F. Especially in level 2, anybody who is in level 2 TLE eliminators, I would highly recommend upsolving till problem F, because now you can do it. Okay. So yeah, I'll be ending it now.
Yeah.
Thank you so much for attending, and yeah, bye bye.